Hello everyone, my name is Hardeep and you are on the Kubernetes show. Today we are continuing our Linux journey with getting started with Linux. This is for some of the users who follow me and they want to learn Linux. I have videos recorded for different topics. Today's topic is Linux process and system monitoring. Uh, One thing I would like to say that system performance and system monitoring is a vast topic. It is impossible to cover in 30 minutes, but I'm trying to give you some insights into some tools that you could use to monitor your systems. Uh, so, when we say monitoring the system, what are we actually trying to monitor? Or what is it that user need to manage? One is processes. Anything that you run, a command that you run on Linux is called a process, right? A script, a service, a command, anything that you run, it's a process. Some are long running processes, some are short lived processes. For example, if you run ls, that's a short lived process, comes, does something, disappears. Long lived processes are that run in the background. For example, your system processes, uh, maybe SSH daemon that allows you to get inside the nodes, right? When you SSH into a system, there is something which is continuously listening in the background. That's how you are able to log in, right? That is another thing you need to think about, the processes. The way Linux system handles these processes, the Linux system assigns a unique process ID to each process. Now let's take a look at two Linux distributions that I have running. One is Ubuntu, another is kind of Red Hat based. So this is Rocky Linux and this is Ubuntu 24 Rocky 9.6. Ubuntu is Debian based. You will use dpkg. Here you use yum, yellow dog update manager, or rpm, red hat package manager, right? That's the only difference. But both of these operating systems manage processes with some IDs, and those are called PIDs. So there is a command called PS. PS is used to list processes. So if I do PS-EF, you can see it is giving me some output, right? So how do I know what is it giving me? Uh, if you see, I typed a pipe character and then I'm sending it to another command called head. Now, before I show you the processes or the headers, I want to tell you the input output redirection. Here, what we are doing is we are redirecting the output of PSEF command, piping it through to another command. So that's a way to basically parse the output. For example, you go somewhere, you buy something and then you hand it over to somebody and say, can you please put it in my car, right? But that person takes away some of it and puts in the car a little bit of it, right? So that's one example how you can pass all the information to something, and that next process can help you to kind of trim down, take out some, uh, you know, help you to control the output. So head command gives you first 10 lines of the output only. So when I do PSEF, pipe head, so what I'm saying, run PSEF, list all the processes that are running and show me only top 10 of this, right? So why did I do head? So head is from top, like human head, right? It is from top. Then we have something called tail also. By default, tail does the same thing, but it is from the bottom. Like in the output, if there are 200 lines, it'll give you last 10 lines by default. Both of these allow specifying a number. For example, by default, it shows you 10 line. You want to see 20, you can do -20, right? With the tail also, you can do something similar. coming back to the topic of processes. So when you run psef, ps is a utility that you can use to monitor running processes in your uh, linux machine, right? First is uid, second is pid. Uid is user id, name of the user who is running this command, right? We see most of the commands are run by root, then process id, then third one is parent process id. We'll talk about other attributes later, but let's talk about these two first. Every process in linux that gets started has a parent id, except there is something called pid 0, which we are by default not able to see. It is basically kernel. When your system boots up, very first thing that happens is your kernel gets loaded, and your kernel is kind of giving you access to your file system, your services, and all that, right? So very first id in linux, people say it is pid 1, but actually it is pid 0. This is your scheduler. That's why I call it kernel, but again, part of the kernel is scheduler, so pid 0 is scheduler. So that is the first thing that gets started. Imagine you are going somewhere, and you know you want to take your family with you, right? You are going on a vacation, so the first person that lands helps to bring others in, right? For example, you guys were going in a boat, you landed there, and then you help your wife to get down, then your kids to get down, right? Similar story in linux file system, exactly similar thing. You have one process that starts everything, then you have processes that are children of that process. There are some commands. For example, there is a command called tree, but with ps also, there is a command called ps tree. So if we do ps tree, do head, then it is kind of showing you uh, a kind of a textual representation of tree like representation of your processes. So if you run, we were using head and tail. If we pass to a command called less, then we have kind of an option where I can press down arrow, up arrow, scroll down, scroll up, and all that, right? So you can see first process is system D, then it has some children. For example, it has here it says modern manager, then network manager. I got VBox running. Here I got a multipath D running. Then it has some kind of a child processes. Same thing, SSHD running. SSHD has kind of a few different processes running. Then this is me logging in, running sudo, and running commands and all that, right? So there are ways you can visualize the processes. By default, process 0 is your scheduler. Process 1 is the first process that when system starts. In most of the cases, PID 1 is your system D process itself. How do we see it? In Linux, there is a special file system called proc. Proc is process, right? It is live kernel related information. Be careful while looking into this file system. Don't try to modify things unless you know, because you can end up making your system get into a bad state, right? So if you do ls proc, lsl proc, you will notice it has a lot of directories, and there is directory number 1, right? If I scroll this window too, which is red hat based, and here also there is a uh, kind of directory called 1. So let's try to type it and see lsl1. If we do lsld, right? So there is 1, and then there should be a directory called exe, right? So if I say lsl, it's not letting me see it because it is pointing to a process or a file which is uh, having permissions for root only. So what do we do? I have sudo access, I can do LSL. Okay. So you notice output, it says cannot read the symbolic link. Basically, it is not able to follow. That's why it is showing in red color. And that's why it was giving me error. But if I do sudo, you can see it is pointing to this one, user lib systemd, right? So sudo, and if we check this, what is it? It is owned by root and it is systemd process. All right, so now we know, the directories, for example, in proc, the one, very first one, first process, and exe for that process is systemd, as I was saying, right? So every process you run has a uh, directory that gets created in proc. So you can, I think there is a way you can do lsl proc self. So you can see what did it do. I This is a kind of special file or special directory self. This is when you run a command where it is running, right? So another thing, you want to figure out a PID of a process, right? So one thing was this PSCF I was doing, right? PSCF grep systemd, right? So it is showing me all these outputs. I know this is PID, this is parent process ID, and then there are other details. But if you want to find the process ID of a particular let's say SSHD, right? Like this is the parent process. Here it is, this 717 is the parent process here in this one, and here we can see it is 951 is the parent process. So you can do PID of SSHD, right? Now it is showing you these numbers here. Okay, similar story here. The number of processes that are running under SSHD with under the name of SSHD itself, it is showing their PIDs, right? So these are some commands that could help you to see the processes, right? We talked about short-lived processes. We talked about the daemons. Daemons are something that runs in background and it helps you to kind of process. For example, SSHD. SSHDD in the end is for stands for daemon. So that's why I have mentioned here. I've given some links. I would say please read through them. Then there are two ways of running commands. One you can run in foreground, another is in background. For example, I've given here, right, sleep 120. So if I run sleep 120 without ampersand, what happens? It has blocked my terminal for 120 seconds, right? I cannot do anything on this terminal, right? This is one way. For example, I ran BC is kind of calculator, like you want to do 2 into 2, it will show 4, right? So control D to exit out. But anyways, example that I was talking about was this BC, right? If you run it like this, it will block your input and you are not able to do anything. All these commands that I am typing, right? Nothing is working. All I need to stop it, control C, right? Then only I can use terminal. But if you, that was called foreground process. Now, if you don't want a process in foreground, but you want it to kind of keep running, right? Then you use ampersand sign. But before I do that, I want to show another thing. So you started a process which is in foreground, but you want to run commands also, right? There is a way in Linux you can use control Z. So control Z, like it shows here, what it does, it sends the process in background, but process has stopped. It means kernel put a kind of stop to this process. It is no longer kind of progressing, right? What if you want sleep counter to keep going, right? Then you will have to kind of bring the process in foreground with the help of fg command to kind of interact with it again, right? So let's send this process in background. If I say this, you can see it gave me a number. This number is nothing but, let me try to switch my terminal, lsl proc this, then exe, right? You can see it is uh, PID of sleep because we are running sleep, and proc this exe, right? It is running sleep here too, right? So the process is running psef grep hyphen I sleep grep hyphen v grep. So why did I had to do grep hyphen v grep? If I don't remove grep from it, it will show two outputs. It is able to grep this also, it is able to grep itself also, right? The process that kind of ran, the transient process, right? The short-lived process. So I wanted to remove that, so I did grep hyphen v. V means remove it from the list. So I was able to see only the process that I have, right? So there is another command which is called L. L is, it gives you the kind of little bit long running, and it also tells you what is happening in the background. This is the kind of system function that is being used. So it says it is sleeping because we did call it as sleep, right? That's why it says sleep. Otherwise it will show as R. If I say grep I R, you can see there is a process psef, and it was in running state. R is running state, right? Some are interruptible processes, some are uninterruptible processes. So S stands for state of the process, and WHN is for what function is being called by that process. All right, let's look at it. So, as I was saying earlier, right, because this is running in the background, the counter was still going, and that counter finished. If I press enter in both of them, it says done. It means 120 seconds it waited and it was able to get out, right? So let's run it on both the terminals. Let's say sleep 120, and now it is running in background. This one, and if I do it again, then you'll see there is a 2. If I do it again, there is 3, right? So what does it mean? There is a command called fg. If I run this, it is kind of bringing up one of these. Okay, so I just kind of did control C, which basically ends it. You can see with the fg I was able to bring in the third one. If I do fg again, it'll bring up the second one. How about if I want to bring in this one first, right? So I can do fg ampersand 1. So control C. If we do jobs, you can see there is number 2 still running, right? And number 1, because I did control C, it is gone, right? So do fg control C, then jobs, nothing. There is no job running, right? So I've seen people struggle with it when they run process, then it blocks their terminal. They feel like, oh, what do I do? There are ways. You do control Z, process goes in background, and let's try doing it, right? Once more. We sent the process in background. That is 1. Now this is 2, but I did control Z, right? So let's see what is the state of these. This one is running because I sent it in background with the ampersand, but this one is in background but in stopped state because I did control Z. So how do I make it run in background without bringing it in front, right? So I can do bg percentage 2, and you can now see it was stopped. Now it is running, right? This is how you do it. uh, all right, so now you know what is foreground, what is background, how to run jobs process, right? How you see your processes, you run psaux, right? Or ps elf. There are many options. It will also let you do something called pseo, like cpu mem. So hold on, like there was something called, yeah, pid, ppid, uh, PCPU, I believe. Yeah, PMEM, COM. Yeah. So PID, like process ID, parent process ID, percentage of CPU, percentage of memory, then command, all that you can do. As I have been saying in my previous videos too, you don't need to remember all this. You can run man command, man ps. It gives you all kind of options what you can do with it, right? Then it also give you -o format option. You can see it is telling you how to kind of do it with the PSEO. If you scroll down, it also tells you the state of each process, like running, stopped, this, that, everything you can find from this, right, with man pages. If you want to find processes for a particular user, then you can do ps-u, right, user. There are tools available that you can use. uh, if you don't want just ps, hold on, let me move it on the side and let's try running a tool called top. This tool, most of the admins you'll find using it. uh, it has many features people don't know, they just use it. But when you run top, you can press 1, for example. If you press 1, it is showing you now CPUs also. If you remove it, you can see I was pressing 1 on keyboard. So press 1, it is showing you per CPU usage. Here I have only one CPU, here I have given two CPUs to this VM. Right? Now it is showing you cumulative usage. Then second is your load average. This is current, this is 5 minutes, and there is 15 minutes too. If I kind of try to make it a little large and that one becomes kind of crumbled, I don't care. But it says there are 4 users logged and it is my user only. I am logged in a couple of times. Load average, your current 5 minutes, 15 minutes shows how many total tasks are running, how many are in running state, how many are sleeping, how many are stopped, and zombie. This process is kind of continuously consuming memory. uh, Zombies don't do any harm to your system, but they can become a problem. You try to send commands to it to kill it, zombies don't get killed because they are kind of dead processes, right? With this screen you also see how much user is using the CPU system, how much is using, how much, what is the niceness value, how much is it idle, waiting, right? Then all this you can read in the man pages of top command. Then it also shows you the memory allocated to these VMs. It is showing you how much is total, how much free used, and all that, right? Then swap usage. If there is more content than what memory could hold, that content goes on disk, and that is what is called swap, and that's what is shown here. Um, with modern systems with large amount of memory, swap is not really needed. But anyways, swap is a concept that you should know about, right? So one tool I was talking about was top. Then there are tools like htop and btop. They are not by default installed. Let's see. Yeah, so this is one side is Red Hat, other side is Ubuntu. Ubuntu seems to have it, but the Red Hat one doesn't have it. So we do sudo DNF update, and then I'll have to do sudo DNF install htop, right? So htop gives you very nice view. So let me double click and it gives you all kind of very nice options. If I press 1, then so it says F1. So if I press Alt 1, or I'm on Mac, so it doesn't let me do the right things. But anyways, it in the bottom it shows here that you can use all these buttons to interact with it, right? So one is htop, another is btop. Btop is not installed, but if we do sudo uh, apt update, first I need to update my repository. Look at this, I don't need this, but sudo dnf install btop htop. Uh, DNF install btop. No, I think I'll have to enable third-party repositories, EPL so-called. Search btop htop. Yeah, I'll have to enable third-party repos, then only it'll run on Red Hat. But on Ubuntu, you can see the difference, right? It is mostly kind of free, open source. And now sudo apt install btop. And you can see it is doing something for me. Looks like it is installing. And let's run btop. If I run btop, you can see it is showing me CPU. It is showing very nice graph on the side. Similarly, you can see F here. This is for filter. C here, it is for parkour view, reverse, then tree, then CPU. Then there are, for example, it is I'm able to kind of interact with the mouse also, right? So command thread, you can do that. But like IO, for example, I want to hide IO, I can press I, and you can see the desk IO is hidden, right? If I say D, desks get hidden, right? Very nice tool. Again, quitting from these tools is very easy. Press Q and you are out. If I say top, press Q, you are out. Top has another feature called -B. It is batch mode, and you can say, run it once only, run it, let's say, twice. So it ran once, it'll run once more, and that's when it gets out. You can specify the time, after how much time it should do it again. So people do sometimes use top in batch mode, right? Then we looked at PID off. If you recall, I was showing you, right? PID off SSHD, then pgrep SSHD, and you can see it is pulling in the PIDs of SSHD, and you can see this is PID field, and it is showing you those numbers, right? um, so PS3 we saw use jobs. Then there is a command called fuser. With fuser, you can list what process is using, or what files are used by a particular process. You can do that. You can list for all open files, right? If you do -a, and you'll have to kind of specify um, name of the file or socket, right? You specify the name of the file, and it'll show you. So let's try proc self exe. uh, since it is a transient process, it doesn't kind of show anything, but let's try doing it on something. Exe. Yeah, so don't have permission because I'm running as Ubuntu. But if I do that, maybe the 688 is gone. SSH, let's see. Let's try doing it on this process, and you can see, different PIDs that are associated with that 1067E is executable, right? PSEF grep-I, and you can see it says, notify. So these are some tools, the ways you can go and find more information about what a process is doing on the systems, right? Which process are using files or ports. You can use fuser for it. Now, to monitor system activity, right? Resource usage. We saw top is one way of doing it. So if I do top, it is giving me all this. I can press H and it gives me help, and I can kind of use it to sort information, right? If I press one, it is letting me see per CPU or total, right? So this is very good tool to get started with, but then there are tools like VMstat. VMstat is kind of a little advanced tool. It tells you how many processes are in running state, how many are blocked, how much of memory is swapped. You can see it shows very nicely, like swap, free, buffer, cache, right? This is memory related columns. Then swap related columns are here. Then IO related columns are right? Blocks in, blocks out, then system related, like context switches, and then CPU related, right? So what do you look at from this output? One, I would say read the man pages. Second, if you have too many processes in blocked state, that's a problem. You have too much, this number is too high in swapped, means your system is starving for memory, and uh, it is sending data to your swap file, and it is reading from that, and it could slow down because your memory is much faster than your disk. When we say swap, it generally is a disk, your input output happening on disk. IO, if you have these numbers very high, by default when you run very first time, it is giving you the total. But then after that, what we are saying, it every 2 seconds do it for 5 times, right? So it is running like it just did once, right? So 1, 2, 3, 4, 5, right? So this is what it does. So if you have these IO high number, like here it shows 0 0, this is good. But if there are numbers are really high, that's a problem. Your system is not getting enough input outputs, and it would be slowing everything down, right? So vmstat is another option. Then there is SAR tool. So with the SAR, there are too many options to mention, right? So with the SAR, for example, you can do SAR H, and it is showing you this SAR A, sorry, capital A. Now with the capital A, it shows you almost all the options it has, right? So I would say look at man pages for all these. Then there is a performance copilot PCP app. I have given a link on this. Read about it. Very nice tool. You should kind of learn to use it if you are getting into Linux administration. Free command shows the memory usage. What is the total amount of memory? So if I say free G, sorry, I don't have in GBs, so that's why it was showing 0. So 952 MB, how much is used, how much is free, how much is in cache? You can drop all this cache, but Linux kind of keeps using it. But anyways, this is another command to see how much swap is being used, or how much physical memory is being used, right? LSOF is somewhat similar to F user. LSOF hyphen I, for example, if I say 22, I'll have to do with sudo. Now you can see I'm able to figure out what is running on port 22. Do I have anything running on port 80? No, right? I have something on port 22. That's how I was able to see all this, right? Then sudo ssTulpn. So ss is another utility that tells you, what is listening, what is there on the system. So if I say grep 22, and you can see it is telling me that there is a PID 951, and that PID is, uh, if I scroll it up a little bit, it's a systemd process, and it has some file descriptors open, and you know this is what is listening on port 22. So ss is another command, lsof is another one, right? Processes by user, processes by a user with the top command htop btop, right? Then I think this is the last topic. So how do you control how many files or how many processes somebody can run uh, on a Linux system? So in Linux, even Ubuntu as well as Red Hat, there is a file called etcsecuritylimits.conf. So this is what defines how many processes. For example, it says nproc, right? So nproc is for processes. This file is very well documented. So if you come here, look at this, it says nproc. So anything that starts with hash, it's a comment, right? So now you are specifying number of maximum number of processes. This is the right way of doing it. You want to control how many processes a user can run, because every process you run, first it is taking some file descriptors, so you can control how many files a user can, there is called number of open file descriptor, no files. So very common, people use this no files in production. I've seen people use nproc. I have seen people use all these nice and other that we were looking at, right? nproc is definitely the one people use. uh, you don't want, if there are 200 users logged in your system, all of them creating 10,000 processes, right? You want every user to run maybe 20 processes, because if all run 200, they might take make your system unstable. It might go out of memory. So that's why this file is important. You make changes to this file, and your changes are kind of instant, immediately implemented. But if you want to kind of see it and bring them in effect, user should log out and log back in. How do you see your limits? For example, for Ubuntu user, if I see ulimit -a, it is showing you all. If I say -n, and you can see number of open files, right? 1024. Yeah. So u limit -l n 2048. I can do this now. If I say, look at this, right? Open files. But the problem with this is user will have to do every time, right? When they log in, there are startup files, login startup files, where people can write these commands. But at the same time, this hard limit also prevents users from going above the kind of specified limits, right? So there are ways to control users so that they don't go crazy and use all of the limits. I've given a link. Basically, this link gives you an idea how people use it in real life. For example, they are installing Oracle, and you can see how soft limit and hard limits are used when Oracle gets installed, right? Uh, I've given some hands-on exercises for you. I would say run through them, play with it. If you find anything which is not clear, you feel like you have questions, feel free to comment on my YouTube video or on LinkedIn. Search for me, Hardeep Singh Tivana, on LinkedIn, and you should be able to find me. I generally post a link on my LinkedIn as well as YouTube. Then you have this link as well, where you can come and, you know, uh, for example, if you come to repositories, go to this getting started, and you should be able to clone from here. Right? Go here, click on fork, because I am the owner. I don't want to do it, but you can create a fork, then make changes, give me a pull request, and I can merge your changes if you have any recommendations, suggestions, to kind of make it look even better. But with that, I'll stop, and good luck. If you have questions, let me know. Looking forward to seeing you during my next video. Take care. Bye bye.